Okay, good morning. Today we'll talk about data processing in machine learning. First we'll go back to machine learning and what's about, just to recap. So remember with machine learning, it's different from the normal classical programming you know about, where you write different if statements. With the normal programming, you write different if statements. So you write rules to be able to get the output. So for example, if you have this and this, it should have this. So you're giving it the data and the roles, and it should give you the output. While with machine learning, you give it the input and the output, and it should learn the rules to get from that input to the output. So we'll talk about data processing in machine learning in this class. So introduction to data processing. Data processing in machine learning involves preparing raw data into a suitable format that enhances the performance of machine learning models. So effective data processing is crucial as it directly impacts the accuracy and efficiency of predictive models by ensuring clean, relevant, and well-formatted data. With data processing, you have your normal data. You want to make sure you fix everything that's wrong with it, everything that's weird, missing, duplicates, and so on. So that is the importance of data processing. So you can have better results, efficient models, and so on. With data processing, you need to prepare your data and engineering features. Data processing involves cleaning, so you need to remove the errors from your data. Transformation, you need to scale or normalize, we'll get to that. Encoding, you need to convert from categorical to numerical representations. Feature engineering, where you create new features or transforming existing ones to improve models' performance. So let's look at data cleaning. Data cleaning involves identifying and correcting inaccuracies and inconsistencies in data to improve its quality. With data cleaning, let's say you're looking at your CSV file, you need to make sure that you don't have any missing row. So like in your Excel file, for each column or each row, you go through it to make sure everything is input correctly. Then you also need, and if there's any missing values, there are different ways you can replace that. You can use mean, median, or mode for that. Uh, and anytime you see data, you need to try and delete one. So there are also techniques for that. Then you can also correct different errors, so fixing data entries and outliers to maintain data integrity. So we'll go through this in the coding section. For the coding session, we'll start with the basic introduction to machine learning or to programming, since there are people that are new to programming. And then maybe in the next tutorial, we'll go into data processing. So in the first tutorial, we'll still have some data processing techniques. So apart from data cleaning, we also have data transformation. So this is just transforming data that normalizes scales and formats data into a uniformly understandable format for algorithms. So remember our housing price, for example. You can have the size of the house that can range from 1,000 to 3,000 square feet. You can also have the number of bedrooms that ranges from, let me say, 1 to 5 bedrooms. But with data transformation, you can put the values on a similar scale, so one does not dominate one. So if you're leaving your features, the size of your house, within the range of 1,000 to 2,000, and the number of bedrooms is within the 2 to 5, for example, it means the size might dominate the one for the number of bedrooms because that one has bigger numbers. So you want to make sure they are on similar scale. So you can normalize it to between 0 and 1, and you can also use standard deviation to make sure they don't differ too much from each other as well. There's also encoding categorical data. So converting categories to numerical values. So let's say you're trying to classify fruits. So fruits have different types. You have apple, mango. You also have colors like red, green, and blue. So the computer might not understand these words. So what you want to do is convert them to numbers. So you can use red as 1, blue as 2, yellow as 3, and so on. So you want to change them to numbers. For example, even with we tried a data set, like a Titanic data set, where one of the features was gender. So that had male and female. So you might want to change and female as one, and then male as something. We also have transforming dates and text. So here we extract usable features from complex data types. So let's say you're trying to classify different shapes, so rectangles, squares, and so on. You have the length, you have the width as features. So as one feature, you have length. As another feature, you have width. So you can create another feature for shapes, maybe call it area, and you can use this length and this width to create another feature. We also have feature engineering. So feature engineering creates predictive features from data, significantly impacting model accuracy. So this is the combination of two or more features to capture interaction effects, like using length and width to create area. We also have dimensionality reduction, so just reducing the number of input variables using to simplify the model without losing essential information. So let's say this let me use like a simple example. Let's say you want to cook or you bake. You have different ingredients. So dimensionality reduction is basically saying, okay, you want to use the ingredient that matters the most. So instead of using all of the ingredients, you just want to use the few ingredients that can still make that particular product. So this dimensionality reduction is simply what that means. So you have different features. Also, if you remember, features are just things that can describe your data. For example, with the housing prices, features were size, number of bedrooms, number of floors, and so on. Okay, and then this will help you get the price of a house. So remember, when you want to predict the price of a house, you can use the size. The bigger the size of a house, the higher the price, right? And you can also use number of bedrooms as well. If you have more number of bedrooms, the price of the house can go up. So this size, this number of bedrooms are features of houses. So you use these features to be able to get a particular output. Then we also have data splitting. Reason for splitting. So data is split into separate sets to train models, validate accuracy, and test before deployment. So if you remember from the first class, when you have your data, you don't want to put everything at once. You want to leave some to see how good your system is doing. So if you show your system all the data, and you want to test, if you're using that same data you trained on, it means you get the correct answer. So what you can do is when you have your data set, let's say you have 10,000 pictures. Let's say you want to predict whether a picture is a cat or dog. So you have 10,000 pictures. You can use 7,000 to train. So basically just showing the computer, okay, this is a picture of a cat, and you're telling it the output, this is a cat. This is a picture of a dog, you're telling it the output, this is a dog. And remember, the remaining 30% will now be used to test. So that 30%, remember the computer did not see it. So it's just going to say, okay, it's going to pick one random image and you'll ask the computer, can you guess what this is? So if you show it a picture of a cat, can it say this is a cat? So if it says this is a dog, that means it did not learn well on 70% of data you gave it. So that is data splitting. And there are different methods of splitting. We have random, stratified, time-based splits that cater to different types of data and distribution needs. So you can do it randomly. Stratified, you can say, okay, you want all representation in both the training and test sets. And with time-based split as well, you can use different timings. This was gotten at this time, this at this time to split. We also have cross-validation. So using techniques like k-fold cross-validation to validate model performance with limited data. So if you have your test sets, for example, um, or your whole data set, you want to make sure that you have passed in everything to your data set, to your system, to what you are training your model. So that one will also see it in our coding tutorial. So remember, machine learning is data driven. So first, you need to collect data of images and their labels or classes. So you can use websites, you can use databases, you can use files. You can also go around on your own to ask people about certain questions. So, like in our last class, we use an example of trying to predict a student's score based on the hours they studied. So maybe you can go around, for example, in school, you can go to each student, you can get the number of hours they studied for and their results. So let's say they studied for 4 hours, their score was 40%, put that in your data set. You can organize that in an Excel file as well. Um, then you can use machine learning to train this to get a classifier. So when you get your data set, you want to be able to see, okay, can you classify this or can you predict this? So remember with machine learning, we had supervised learning, we had unsupervised learning. So remember on under supervised learning, we had classification and we had regression. So with classification, you're trying to know which particular output you want to get to. So for example, let's look at this image on the screen. We have cat, dog, mug, and hats. So classification, when it picks a picture, it must either say it belongs to the cat class, the dog class, the mug class, the cat class. So classification are just categorizing. While with regression, it's more about continuous values instead of discrete. So continuous just is just a range of values you can um, you can predict. So for example, age of a person. Um, Someone's age can be 5, 13, 25, 40, etc. So that is continuous values. So when you're trying to predict the score of a student, that one is also continuous. So if there's no exact class it should fall into, then that means it is regression, continuous values. So when you're using machine learning to train this, remember you use what? If you remember what you need to do when you have your data sets, the different processing techniques. Yes. So we have data collection, right? First, so you need to collect the data, which was the first thing here. We have the cleaning. So you need to make sure you have what all the your there's no missing value. So you go through your file. So there are easy ways to go through, which you'll see in the tutorial. You need to then input. You can use main, you can use median, and so on. Then the next one you can transform as well. So you can also normalize. So remember, if it's a wide range, for example, let's say you have number of remember in example number of bedrooms. It's might range from 2 to 5, but with the size of the house, it can range from I'm just using random numbers, 500 square feet to 3,000 square feet. So that number, remember, 1,000 is way bigger than 5. So the size of the house, which is 1,000, will dominate what the number of bedrooms because one has way bigger values. So you want to make sure they fall in the same range. So for example, you can normalize it to fall between 0 to 1. So the size of the house, let's take 1,000 square feet. You can divide by the biggest number. So maybe 1,000 divided by 2,000, and that will give you 0 point something. The number of bedrooms as well, you can do if the house has 2 bedrooms and the highest in your data set is 5, you can do 2 divided by 5. So you can also get the mean and so on. So and then another thing you need to do is split the data sets, right? So remember, splitting is to help you evaluate. So the training part, let's say you have your data set, you want to split, you can say 70-30 split, you can say 80-20 split, 90-10 split. So let's say you say 80-20 split. That means you have what 80% to train. So it means you're going to put 80% of your data to the system. So as you're giving it a particular input, you're going to be telling it the output for 80% of your data. And remember, the remaining 20, you use it to test. So you test this classifier on a different set of data, so excluding the ones used for training. So that is because when you're teaching, for example, if someone is teaching you, they want to give you a different example to actually see if you actually know it. So with that, you can now get the accuracy, how well your system is doing for that. Conclusion of this particular note. So proper data processing is foundational to successful machine learning, ensuring clean, relevant, and well-structured data. So and you embrace robust data processing practices to enhance your predictive modeling efforts. So with data processing, you can get better models, so you can have higher accuracy. So let's say you see, okay, your system only has 70% accuracy. Maybe when you perform some data processing techniques, you see that, okay, you can increase your accuracy to 90%. So by accuracy, I just mean how good your system is doing. So if you have, for example, 100 pictures of in your data set, let's say the cat and dog example, for example, let's say 50 are dogs. If you can get 90 of those images correctly and 10 wrong, it means your accuracy is 90%. So that's just why by accuracy. The amount you got correct, the percentage of pictures or of data you got correct in the test set. So we'll go through a simple basic programming notes. So for people that know programming, and then this so put it a bit. I just used the relevant things you need for machine learning, but I sent a link to the Telegram group, which you can use to advance your Python knowledge. But for now, we'll go through the basic things we might need for machine learning. So you can also bring out your laptop. So I'll just give 1 minute for that set. But any questions so far for the data processing part in class, then at the end I'll ask those online. Any questions?
That this is a orange, but you know that the orange are in same shape. So how can your machine understand that this orange and this is a apple?
Okay, so one thing you can do.
Same.
Okay, so one thing you can add is things that will help get them to make it different. So apart from length, use color. You can also use shape. So remember, there are different. The shape of an orange is completely round, but the shape of an apple has a different curve. So you can use a feature called gradients to see how it slants and so on. So when you add that feature, so apart from length, width, you can have color and then you can have gradients to see how they orient around.
Orange.
Yes.
Why they are in the same color?
Yeah, so you have to use other features as well, like the gradient features. You can also use textures as well. So one thing you can use is an advanced one, so not just the machine learning, the neural networks or CNN, which you will learn in another class. With CNN, you can pass in images. You don't have to pass in numbers like you'll see here. You can also take a picture of orange, different pictures of oranges, different pictures of apple, and then the system will be able to know about that. It should be able to recognize the edges, the textures, and so on. So maybe in the next model, we will learn about neural networks. So from that, you might see CNNs, which you will learn that the first part of the neural network is to learn different edges, then it will learn different textures, then the whole object. So you can use more advanced features for that, more advanced algorithms. Sorry for that. So any question here? Okay. So you all have. If you came with your laptop, so if you don't have laptop, you can just share with someone for now. Oh, okay. Okay, so I saw a question like, is there a particular software for data processing? So yeah, there are different softwares. There are different softwares you can use. Like, for example, you have the Orange. You can search Orange data mining tool. That, and then also in our tutorial, in the next tutorial, you also see different ways you can use code to clean your data. Sorry. Yes, that's what we're about to do. The practical part. Okay. So with feature engineering, so someone asked for more light on feature engineering. So it's just basically trying to create one. There are different ways of feature engineering. So remember, features are just things that can describe what you actually want to classify or predict. So let's say you have shapes, for example, and you want to classify if this particular shape is a triangle, rectangle, or sorry, rectangle or square. You have different lengths and widths, but you can also use area as an additional feature. You can use if it's about people, you can use someone's the average of someone's width and height as another feature. Sorry, weight and height is a particular feature. And then another question. Okay. Okay, so maybe at the end we'll come back to this as well. So we have simplified Python programming tutorial for machine learning beginners using Google Colab. So introduction to Google Colab. Google Colab is an online platform that lets you write and run Python code through the browser. It is particularly useful for machine learning projects because it provides free access to GPUs, that's graphics processing units, which can speed up the computation needed for machine learning. So with the normal system you have CPUs, but they may not run on with large data or heavy algorithms. So you might want to use GPUs for when you have large data, for example, graphical processing units, not the computer processing units. So getting started with Google Colab. So first you go to Google Colab. So to get there quickly, you can just open your browser and search Google Colab, and then click on the first or this one, the collab.google. Are you there? So if you haven't yet signed in, so sign in to your profile. So I'll give about 1 minute for that. So start Google Colab, click on that link. If you're not signed in, then sign in. If you're already signed in, click on new notebook. So you should see something like this. So when you click on new notebook, this should appear. Okay. So remember, search Google Colab, click on the first one. So the link is collab.research.google.com. And then you should have this page. So click on new notebook once you have done that. Okay. So on the same page, right? Okay. So the next thing, so Python basics in Google Colab. So we'll write our first program. So the task here is to print hello machine learning to the screen. So we'll type the following Python code into a new cell in our Google Colab. So and to do that, anytime you want to display something to your console, which you see, you use print. So in Python, it is called print. It might differ in other language, but Python is print. So let's try this. So are you all here? Okay. Okay. Yes, you can, but you have to. Python installation, but with Google Colab, you don't need that. You can just do it directly. So if you want to print, you type in the print keyword this way. Sorry. And anytime you want to print something, it comes with this bracket here. So this parenthesis here. And if you want to print something that has not, okay, we'll go to variables soon, but first just put quotes for now. So quotes will print something exactly as it is. Excuse me. Sorry, I need quotes. The quotes on this one. Okay. Okay. Okay, so if you want to print something, you do this, hello. And the task was to print hello, hello machine learning. So this way. So if you want to run this, you see this arrow here? Sorry, this run button here. That looks like a play button. Just click that. Okay, so see the output here. So this is a way to print in Python. So anytime you want to print, you write print hello machine learning, and then it will display it for you. So that's the first thing. The next part, understanding comments. So the hash symbol is used to start a comment in the code. A comment is a line of text in your program that is not executed as part of the program. Its primary purpose is to annotate the code to help programmers understand the code's functionality or intent more easily. Comments can also be used temporarily to disable parts of your code during testing without deleting it. So for comments, you need the hash symbol. Also, when you want to add another, you can, if you want it in the same cell block, that is this, you just need to press enter. But with Colab, you can also click, just put your mouse down till you see this code here, this way, and then this cell block will appear for you. So if you want that, you can use the hash for comment. So this comment is not going to run, the compiler will not run it, or it will not execute. So it is just for you, the programmer, to understand. Or let's say you're coding with somebody, you might want to leave a comment for the next person to understand what you have done. So I can say below line, print something. So if I run this, it's a way for me to just leave a note. It's not going to affect the code or anything. So I can also print something else again. Hello. Like this. So you just need to put the hash before that. So if I would have put the hash here before this prints, nothing will execute because, so it's not printing because this is a comment. So it's not going to be runnable. They understand? It's not going to affect the code. So we have, so that's using comments. The next thing is understanding variables and basic data types. So with variables, think of variables as containers that store data values. You can name them whatever you like. So data type, Python has several data types, including integers, floats, decimal numbers, and string text. So with variable, just think of it like somewhere in your computer, you have, let's say, a location in your memory, in your computer. Um, that is what a variable is. So you can store something in a particular location. So variables are just name location in computer memory, basically. So for example, age equals to 25. So variables can hold integers. So the good thing about Python is you don't have to specify the data type you want. So let's say you want a number. They're usually called integers. In some other languages, you have to specify int and then the variable name. But with Python, you just need the variable name. So for example, this first part, int 25, it means we want to put the value 25 into a named location called age. So let's try this. So let's say we have age equals to 25. Your equal sign. Your equal sign is not working. Okay. Okay. So if you have it, so if I have age equals to 25 this way, it means I'm storing the value 25 in a variable called age. So anytime I want to print someone's age, I can directly print age here. So this time around, can you see we don't have any quotes? In this particular hello machine learning, we had quotes here. Did you see, can you see this double quote? But this time around, this age does not have quotes. So anytime you're running prints or calling a variable like this without quotes, something without any quotes, a word without any quotes, it's going to go into your memory and try and look for anything to save with this particular name here. So for example, we saved age here. We've declared it here, age equals to 25. So it means we have something called age. So I can print this and it can give me something. But let's say I try to print name like this. It will give an error. So the 25 was able to print, but the name, so name is not defined. So this is because we don't have something previously with name. So you must always declare whatever you're trying to use if it does not have quotes. So for example, I can put name equals to Khadija, for example. So with this particular one here, so remember, with this Khadija as well, I'm also putting quotes. If I don't put quotes, it's for something, a variable called. Do you understand? So with this one, I have to put quotes this way. And then now I can print age, whatever I have stored in age and whatever I have stored in name this way. Okay. So we also have other data types. We have float as well. So for example, height equals to 5.9. So this is a float. So float just basically means decimal numbers. So in other programming languages, some other programming languages, for example Java, you would have to declare the type of this height. So you might have to put float height or double height equals to 5.9 to specify that it is decimal. But with Python, you don't need to specify the data type. You just need to specify the variable name and give it a value. So here I can change as well. And then I can also have text. So for example, I can have course equal to shall I enter it? So the numbers, whether whole numbers or floating point numbers, you don't need to put quotes. But when it comes to words, you need to put quotes. If not, it's going to go into your memory and try to find that particular word. So you can also print all of this together. You can separate them. or you can put print height, and print cost this way. So this is just how to print it on one line, so separated by comma, like this. So this is just the simple thing we've done. We've been able to print. You know about comments and you know about variables. So we'll go to the next section. So you've been able to have basic knowledge of simple programming. We'll go to the next one. So session two, working with lists, dictionaries, arrays, and you also see import statements in this session. So working with lists. So the purpose, this stores multiple items in a single variable. For example, let's say you have something like fruit this way, apple, banana, cherry. You want to store everything. So just like normal list you know about, you want to store every item you have in a particular variable. So in this case here, previously, we just stored one word, right? So this is a single variable, a single integer. So integer are just whole numbers. We store it in one variable. We can store different things in an item. So for example, we can have fruit equal to the different fruits we know about. So we have apple, we have orange, we have banana. So this way. So here, instead of just having one value, this type of variable, like this string here, because we can have different items, and this is called a list. So you have your square brackets to indicate that, and then you have the different items separated by a comma, like this. So you can print all the items in your list. So for example, print fruit. So remember, fruit will not have quote. If I put quote, it will, let me show you the difference. So if I run this and I leave the quotes, it's going to print out fruits like this. But if I remove the quotes, it will now print out the items I have, the list. Do you understand? Okay. So we also have dictionaries. Purpose dictionaries hold data as key value pairs, which is similar to how a real dictionary works with word definitions. So remember, you have the variable name first equal to what you want. So with dictionaries, they use what curly bracket here, and then you have the key, for example, the name, so just the property, and then you have the value here, John. So key value pairs. And you can also say age as well. You can say 22. So they are separated by commas, and when you write the key, you put a colon and then you put the value. So let's try that as well. So the dictionary student with the curly brackets. Okay, this way. So you have key here, and then the value here. You have the key and then the value. So that is basically how dictionaries work. So the next one, okay, print. So you can also print this if you want. So remember, you can also write all of this in the same code block. You don't have to separate them. Sorry, also remember it's case sensitive. So if you're using small letters, you should make sure you're using small letters as well. So this way. So that is list and dictionaries. So we also have something like array. So an array is a data structure that stores a collection of items. So in programming, arrays are used to organize data so that a related set of values can be easily sorted or searched. Unlike Python's built-in list type, which can store items of different data types, arrays typically require all elements to be of the same type, making them more efficient for certain operations. So just that this was a fruit example, but if it was a random example, you can have, apart from things in quotes, you can have different numbers if it's a list. But with an array, all of them must be the same data type. Remember, we have different data types that's just describing that particular data. So a variable can be an integer, which is whole number. It can be a float, decimal number. It can be a string, which is text. So those are data types: integers, floats, strings. So there are also different other data types as well. So arrays in Python can be created and manipulated using the NumPy library, which provides a high performance array object that is central to doing numerical operations. So in the code for the last class, there was something about NumPy, which we'll also go back to anyway. So what is import? So in Python, the import is a keyword used to include the code contained in another Python source file. In other words, import allows you to access and use functions, classes, and variables defined in other Python files. This is particularly useful for accessing Python libraries, which are collections of models that include pre-written code you can include in your projects. So when you import something, it's just basically saying you want all of the usage of that particular item in this particular file. So there's something called NumPy. It's just to help you deal and you can manipulate different arrays easily, different objects easily, functions, and so on. So if you write import NumPy, it tells Python to load the NumPy library, making all of NumPy's functions and features available in your scripts. And to do that, you simply just need to write import NumPy this way. So it means you're importing all of the features and so on of NumPy. So you can, I remember with NumPy, you can manipulate your different arrays and so on. So what does the AS do in Python? The AS keyword in Python is used in conjunction with the import statement to create an alias for the imported model. This lets you refer to the model with a different name, usually a shorter one, which is handy if you need to call it frequently in your code. So this import NumPy as MP is just simply telling you that anytime you want to use NumPy, you want to call it MP. So NumPy, which stands for numerical Python. So here an MP is here MP is an alias for NumPy. This means that instead of typing numpy.array to create a new array, you can use the shorter mp.array. So remember, because we put MP as NumPy, it means anytime we write MP, we're referring to NumPy. So instead of writing this numpy.array, you can use mp.array. So just a shorter way of doing that. So what is NumPy? It stands for Numerical Python. It's an open source Python library that is widely used in data science and scientific computing. It is known for its powerful array objects, but it also provides functions for performing complex mathematical and logical operations on arrays. So you have different tools for integrating different codes, and you can use it for linear algebra, Fourier transforms, random number generation, a lot of things. NumPy arrays are faster and are more compact than Python lists. An array consumes less memory and is convenient to use for mathematical operations, particularly if you have to perform operations on large data sets, which is typical in machine learning and data analysis tasks. So example of using NumPy, here's a simple example that demonstrates creating an array with NumPy and performing a mathematical operation. So first, you just need to import the NumPy library and give it an alias MP. So this is optional. If you want, you can still use NumPy.this, NumPy.that, and so on. So first, you create an MP array. So remember this part here. The left part of the equation is the name of the variable. So remember, when you see this equals to, when it's 1 equals to, you're putting what is on the right-hand side into what is on the left-hand side. Remember when we had age equals to 25, we put what was 25 into what age. So what was on the right hand side into age. It means when we tried to access what was on the left hand side, it gave us the value of what was on the right hand side. So creating a NumPy array. So you have something like this: r equals to mp.array. Copy this. You have this is the variable name now, ARR, mp.array, so 1, 2, 3, 4, 5. So this simply means you have what? 5 different items. So remember, with an array, instead of having one, like the normal integer variable you know about, with arrays, you can have different numbers. So you can store 1, 2, 3, 4, 5 into a variable called r. And remember NumPy, if you make it a NumPy array, mp.array, it will help with easy manipulation and so on. So now the next thing we want to do, we can perform an element-wise addition. So one good thing about this NumPy as well, so and Python, instead of using a for loop, let's say you want to add 5 to each of the numbers in the array, so everything inside that, each element in that array. Instead of using a for loop, so if you program, there's something like a for loop which can help you go through it one by one, and it runs longer than the normal single line code that you have single initialization. Well, that's if you know programming. So if you want to add 5, because this is Python and NumPy, you can easily do +5 on every single thing in the array, and you can have a new output. So copy this now. Previously, we had what? R equals to mp.array 1, 2, 3, 4, 5. I can now create a new variable. If I want to call it new R and use this previous array here and just add 5 to it. So let me do that for you. Okay. So here, so this first line is just creating an array with 1, 2, 3, 4, 5. So you have 5 different elements. And the next one is using that particular array. So this 1, 2, 3, 4, 5. It's going to add 5 to everything. So remember, if you add 5 to everything in what you have in this R, this 1 will change to 6, this 2 will change to 7, etc., 3 to 8, and so on. Which is just what you have in ARR plus 5. So let's print this to see if it works. So can you see the new values of the array? 6, 7, 8, 9, 10. So this is just what we mean. So this example shows how to create a NumPy array and then adds a number to every element in the array using NumPy's ability to handle vectorized operations efficiently. So such capabilities make NumPy an invaluable tool for data processing in Python. So we can also move on to the next part. So any questions from session 1 and session 2 so far? Okay, so slower, okay. Yeah, so you need to check for any syntax error. So sometimes you might be missing a bracket, a comma, and so on, and those things can give you an error. Okay.
Now, my question is from why difference between the first um, demo on the simplified one? After the on the output, there's print brackets. Then on the last step, there's also on this array, there's also you also after the bracket, you put new then on the shoe. Is it the process is different or
Oh, okay. So this is just the name. You mean this part here, right?
yes?
Okay, this is the name of the.
The first one under the output is different from
Oh,
this,
okay.
this maybe I don't know whether the
Oh,
process
okay.
is
So
different
you
or
mean like instead of printing this, right?
yes.
So remember, let me separate them with a space. So this ARR here, can you see this one here? We have what? 1, 2, 3, 4, 5, right? Can you see it? So this, if we print out ARR, it will give us 1, 2, 3, 4, 5, right? But remember, we created another variable called new underscore ARR. So the new variable is name underscore ARR, and it's just saying we want this R to have the value of 5 added to each thing. So if we want to print that, this second one here, this new value, where we're adding 5, we put print underscore, sorry, print bracket new underscore ARR. So if I would have changed this, let's say I call this NARR like this, it means I'll have to change this one. So I'm just using that because of what I saved it as. So the variable here, if it's now called nar, I'll have to print out nar instead of the new underscore ARR. Yes. Yeah, so it just depends on what you name the variable as. So remember, you can name this variable anything. So even this age, for example, I could name this age 1 if I want. Well, you can't start with a number. You must start with a letter. Yeah. Or there are different conventions you can start with underscore etc, but you can't start with a number. So I can put age 1 here, but this age, remember, is now called age 1. So I'll have to change this when I'm printing age. Do you understand? So that's what we mean. So you can name your variables anything. So for example, I can name this first array. Let me put first array like this. And if I want to print out this first array, um, I'll have to write what? First array this way. So let me put this in a comment first. So like this. So it just depends on what you named it as. So if I'm using first array here, I'll have to use first array here. So that's what we mean. So, and then whatever I'm using here as well. So since I changed this, the name of this array to first array, I also have to change this R here if I want to use this particular array to the name here. So for example, first array this way. So I can print the first array, which is what I have, and then the second array, which is my first array plus 5 added to everything. Do you understand? Okay. Sorry? Yes, it's the same thing. It's just variable names that change. So let me just go through session 1 and session 2 again before we go to session 3. So remember, if you want to print, you just need the print keyword. So print here, then you open parentheses. So this bracket, this particular bracket here, so it's commonly on top of 9 and 0. So that's the one we use, the circle bracket. And then inside that, we have quotes. For example, hello. Mm, okay. Okay, yeah, so those online, you couldn't see it. But I think it should be a bit clearer now. So if you have print, hello machine learning, it means you're going to display whatever you have here into your console. So I can print something else. So welcome to Artificial Intelligence Lab. So remember, I have print, right? Then the parentheses, open parentheses, then the word I want to print. So for example, remember to use your quotes if you've not studied before. So welcome to Artificial Intelligence class in quotes here, and then close the parentheses this way. So in some programming languages, you will need to write semicolon, but with Python, this is still okay. So like this. So hello, machine learning. Welcome to artificial intelligence class. So this is just what we printed. And then if you remember comments, so comments will not, it's just for you to understand. So it is not going to execute. So if I would have put one of this in comments, so let's say I put the first one, if I put hash, remember hash is to give a comment. So if I would have put something like this, it is not going to print out because of the hash symbol. So comments, so this hash, they're usually used to maybe remove something in your code for a short while. You want to say, okay, this might not be working. Instead of deleting it, let me put it in a comment. But commonly, it's used to explain what you are doing. So for example, below line, um, I used that before. So this is how to print. So also when you're working with somebody, it's useful to put this comment here, like this. So other programming languages have their own types of comments. So if you're using Java, you use slash slash, for example, two forward slashes. But with Python, it's the hash symbol. So the next one is just comments, so nothing will happen. And then the next one, variables. So it's just containers for you to be able to keep different values. So you can name it whatever you want, but make sure you don't start from a number. So if I would have used one age one here, this would give an error. So I can create different variables. For example, I can put university is what it, for example, like this. So this is just going to give this university variable here a value of base. So anytime I try to access this, the value will have base inside. So other things you can use score. So remember all this score, use university, this score, this H1. It depends on you. You can name it anything you want, like this. So you can also print. So you can print this way. So anytime I'm printing without quotes, like this, it's going to go into here and check for anything that doesn't have quotes here. So also remember, it's also case sensitive. So if you're using all small letters, make sure you're using all small letters when you're calling it. If anything is capital letter, so let's say this R, for example, was capital. That means this one is a different number. So this university here with capital R is different from this university with small r. So if I run this, it's going to give an error because so far in my code, I've not created anything with any university with small r. So I'll have to change this one here for me to print this way. So I can declare different variables. So this university is equals to base, 4 is equals to 90, H1 equals to 5, and I can print that here. So I can print another thing if I want, age this way. So if I print out age, it's going to give me an error because I called it H1. So H1, so like this. And you can also print different things. There are different ways to print. So one way, if you want to print out multiple variables, so one way is to separate it by a comma. So for example, this H1 here, comma height, comma cost. So it's just going to give you spaces. So 25, 5.9 artificial intelligence. You understand? So remember to make sure you remove the quote as well if you already have it. So remember, because this is not printing out base, because I left it in quotes. So remember, if it's in quotes, it's going to print it out exactly as it is. So that's variables. And we also have list as well. So if you want to print out put different items in a particular variable, you can use lists. So for example, this one, I have a list of apple, orange, and banana. So instead of just having fruit equals to apple, so if I wanted just one fruit before, I'd have had something like fruits equal to apple, right? Like this. But if I want different collection, different items stored in one particular variable, I can put it in a list. And remember, a list will have this square bracket here and another square bracket here. So you can put a list of other items. So let me remove this. So I can have a list of, let me say, courses. So remember the square brackets. So in these courses, I can name one programming one. I can name another one web programming. Another one artificial intelligence. This is AI. Okay, so let me just quickly go through dictionary again since the mic was off. Dictionary, if you have a variable here, students, remember what's on the left-hand side is what the variable, this equal just means an assignment. So you're putting what's on the right-hand side into what's on the left-hand side. So with dictionaries, they come with what? Curly brackets and key value pairs. So if I want this student, let me name it student 1. If I want student 1 to have the name as John, this is the key, right? The first part is the property. Then you have colon, the value, John. And then you can have age for that particular student 1 and the value of age. I can also have student 2. So student 2 can have their own name. For example, Amina. And then you can have age as well. So this way. So this is another dictionary. So this student 2, the name of this student is Amina, and then the age 19. You can print out student 2 this way. So just like this. So this is what a dictionary is. You have your key value pairs. And then we went through NumPy. So with NumPy, just for easy array manipulation. So if you want NumPy's feature, all you have to do is put import NumPy, and then you have all of its features. And there's also something called an alias. Instead of writing NumPy every time, you might want to use a short form, for example, as NP. So this way, anytime in your code, if you have something like NP numpy.array, you can write np.array instead. So that's what this AS keyword is for, to help you for a shorter way of writing your code. So instead of this long word here, you can just use 2. You can even use 1 if you want. You can use n if you want. So it's just a way of saying you want to call NumPy NP. So remember NumPy, you can use it to create an array, for example, np.array, and this is how an array is created. You just use your square bracket, just like how you had with the list, and then all the items you want. So if you want an array with 5 different numbers, you do this. So 1, and you're separating them by comma, remember. So 1, the first element has the value of 1, the second element 2, third one 3, fourth one 4, fifth one 5. And you can print this array. So let me remove this first. First array this way. So if I have np.array 1, 2, 3, 4, 5, and I store it in a variable first array. So remember, you just need, when you want to print, you just need to call the name of the variable this way. So remember, I can also have something like this. You don't have to use 1, 2, 3, 4, 5. It can be random numbers. So 5 to 3, 6, 5 if you want. So remember, it's your choice. You give it the value you want, and you can name it whatever you want. So here we named it first array. We can also have another array, second array. So if I want, I can have something like this. And then I can print this array. This way. Like this. So remember, with arrays, you must have the same data type. So I cannot add another string here. Like I cannot put something like this because the data type is different. So like this. So I can also manipulate this. So because I'm using NumPy, I can easily, if I want to add the value of 3 to everything in this array, and then store it in a new array. So I can call that array new array this way. And I can, if I want to add everything to the second array, I can put second array plus 3 this way. So it means in this second array, which is this here, 1, 2, 3, I can add a value of 3 to each of them. Or if I want, I can add a value of 20 to each of them. So let me say print new array. So I've used this second array here to create a new array. So second array plus 20, it means it's going to do what? Add 20 to 1, add 20 to 2, add 20 to 3. So that means that's why the new value is 21, 22, 23. So that's just the meaning. So, and also one good thing about Python and NumPy, if you look at other programming languages, sometimes you have to use a for loop to go through each of them. But with NumPy and Python, you just need to add plus when you're doing that. Okay. So so because of the time, I'll just quickly go through section 3, and then we'll continue this in the next tutorial. So section 3, data handling with Pandas. So introduction to Pandas. So Pandas is a library that simplifies data manipulation and analysis. So for example, when you want to read some documents, you can simply use Pandas as well. And if you remember the import Pandas, can anyone remember import Pandas? Import. If you want to get what all the features of Pandas, you can use import Pandas. And remember this as here, this as here is what an alias. If you want to use as PD, so import Pandas as PD. It means instead of writing pandas.this every time in your code, you can simply use PD.this. And you have URL equals to this here. So I'm just going to copy it. Okay, so this is what we have here. So when you get the link, all you have to do, okay, let me send the link now to the Telegram group. Okay, I will send it in a bit. But when you get the link, all you have to do is when you open it, if you want to see this written in an Excel file, just simply right click on save as. So Titanic CSV file is a CSV file, so just save. So if you go to your document now, okay. So you can simply open it with Excel. So when you open the Excel, it will give you different rows and different columns. So all of this, you'll see the top part will have what passenger ID. So if you open an Excel file, passenger ID, survived, P class, and so on. And then you'll see the different values of each of them. Then another thing you can do is read this. You can use Pandas to read this CSV file. So pd.read_CSV. So anytime you see read_CSV, it's just the code for you to be able to read a CSV file. And then you put the URL or the path to that file inside the square brackets. So let's try this. So you have import pandas as PD, and then you have this URL here. So HTTPS, this long CSV file which you'll get. So remember, this is a variable, right? So we are putting the value of whatever we have on this right-hand side here into this variable here, URL. And with pandas, you can easily read a file. Remember the reason why using PD here is because remember we call pandas PD, right? So instead of writing pandas or read_CSV, we write pd.read_csv, and then in these parentheses we have URL here. And then that means this whole file is going to be stored in a variable called data this way. So you can run this if you want. Then we also have basic data. So also, if you want to read the first 5 rows of the data set, you can use this code here. So print data.head. So like this. So remember, you have passenger ID, survived, and so on. So because of space, it is continuing on the next part. But this data.head will give you the first rows. If you open the CSV file when you get home, it will give you the first 5 rows. So row 0, it starts at row 0. So row 0 has this, row 1, row 2, row 3, row 4. The passenger ID is 1. The survived, so we'll go through what they all mean. So survived 0, survived 1, the class they were in 3, 1, 3, and so on. So we also have statistics. So get a summary of the statistics pertaining to the data frame. So if you want to use this, get the summary, you use .describe. So when you wanted to view the first 5 rows, you use .head here. And if you remember why data is here, remember here, we stored pd.read_csv URL, our CSV file, in a variable called data. That is why we have data here. So print data.head will give us the first 5 rows of data. So that's what .head is for in Python. And then .describe will describe what you have stored in data as well. So let me print out data.subscribe. So it's also just going to give you, like, for example, count of each row, mean of each row, standard deviation, and so on, minimum value, anything you want. So it's giving you statistics of each row in your data set. So you'll see that when you get to your computer, you'll see you have 891 values on passenger ID. So when you get this, you'll see that. There's also further explanation as well, which you can go through. And then there are the key columns in your data set. So passenger ID, so it's just an identifier for the passenger. So each passenger has different values, 1, 2, 3, 4, 5, all the way up to 891, since there are 891 passengers. Survive, whether the passenger survived, 1 or not, that's at 0. So remember, from this particular class, data processing, we said what, if you have different words, you can decide to change categorical values into numerical values, right? So your computer can understand easily because they understand numbers better. So instead of using survived and not survived in the rows, you can use 0 and 1. So you can use 1 as survived, 0 as not survived. Then P class, the passengers class, first, second, or third, which is proxy for socioeconomic status. So remember, we're also not writing first, second, or third. You can use first as 1, second as 2, third as 3. Then the name of the passenger, you'll see that it's not, you might remove this from your data sets when we go through it. The gender as well. So gender comes to what, male and female. So you might want to change that. You can use female as 1, male as 0. Passenger's age is already numerical, and so on. In the Titanic tutorial, which we'll see, you'll see that some of the age values are missing. I remember from data processing, from this class, you need to do what? Input missing data. So you can delete it, but since we only have 891, we can just input the missing values. So the age column is not complete. Oh, okay. So you can use the median of all the age or the mean of all the age. So we'll continue with this tutorial. But for now, just go through the code we have. So I'll post this note on the tutorial. So try and go ahead so we can go back to the tutorials from the previous classes. So any question? Question from class? Okay.
Sorry, I want using columns, and you let's say instead of putting really a space, you put like dot spacing. Will it affect the when you want to run the program? Will it affect
Okay, so
spacing doesn't matter?
it's still going to be empty. So what you want to do is also make sure you're changing those spaces to numerical values as well, or deleting it. Okay. Any other question from class? Okay.
Because I don't understand this pandas green underscore
CSV. Okay. So with pandas, it can help you to manipulate your data. It can help you view your data, describe, and so on. So that's one thing about pandas. So you import pandas, and we imported it as PD. So instead of using pandas, we're using PD. So that read underscore CSV. Remember, in the brackets, you had a long URL, right? HTTPS etc. So your computer will not just read it automatically. That read underscore CSV is that keyword there is something that can help you read Excel files, or sorry, read CSV files. So if you see read underscore CSV, you're just going to read whatever is in that bracket. So you can also use it to understand what you have in the data. So if you have PD or read underscore CSV, since you're using pandas to read it, it means you can also describe it using that variable and so on. Okay, do you understand? Okay, so any other question from class? So no more questions? Okay, so let me just check online. Also, yes, so the variables are case sensitive. So if you're using all small letters, it means everything should be small letters. Anywhere you have capital letter, you should change it to capital. So there are different applications you can use to visualize and then clean your data. For example, Orange Data Mining Tool. But for this class, because it's under AI, we're using programming. So Python to help us clean our data and so on. Okay, so in next class, I'll show you how you can use error messages to know where the problem is. So different between brackets. So when you want an array, you use the square brackets, dictionary, curly bracket. When you're printing or a lot of things, you use the parentheses, the circle bracket. Yes, you can generate odd and even numbers, random numbers, and so on from arrays. So for the code, you'll see the tutorial on the classroom. So it's just what you need. You basically need to write. Okay, so the semicolon to hide. So in a lot of programming language, like with Java, when you write a statement, you need semicolon. But with Python, it's not compulsory. So you can remove the semicolon after the height. You can put it, but you can use semicolons to also separate two different statements. But you can remove that one from the height if it's confusing. So that one I added to the age, it was just to show that you can name your variables different things. So age 1 is different from the variable age 2 is also different, and so on. So an array just to store values of the same data type, similar values together. So CSV file. So the one I have on the tutorial is online, but you can also have one on your system and just put the paths linking to the system. So it depends on you. Yeah, you can read it from your local disk. So the code for this class, we wrote the code, but it's available online. So with one simple search, you can find all AI codes. So I think that's all. So that's the last lecture. And then the notes, I'll upload it on the Telegram group. So I think that's all right. Okay, so thank you very much.